observing, we drive up to the mountain in the mid-afternoon. Then we will start up and do a walk around both telescopes to make sure everything looks good. The 1.8 meter and 0.9 meter telescopes that we use are on Kitt Peaks. And the 0.9 meter telescope is actually the original Stewart Observatory telescope that started off on campus in 1922. One thing we need to do is choose our first targets and then start up all the software that we need to operate the telescopes. Then we also do a pointing to make sure that we're pointing exactly where we want to be pointing in the sky. And then we're ready to start taking images of asteroids. I'm Melissa Brucker. I work for the University of Arizona in the Lunar and Planetary Lab, and I'm the Principal Investigator of Spacewatch. And we use telescopes on Kitt Peak to measure the positions of asteroids to make sure they don't get lost. Why don't we check out this one up here?
Okay. May I zoom in?
Sure.
Okay, so go ahead and stack the blink, right?
Yeah. It may possibly be rotating. It looks a lot brighter in the last image.
Yeah, and the stars appear uniformly.
So at Spacewatch, there are 7 of us who operate the telescopes, including me, and we can have anywhere between 24 to 38 nights per month on the telescope.
I always click this button, ping all, and dismounts. And these both should be normal. So as the lead engineer, I go up to the mountain once a month to start the run. Starting the run is an all-day activity where I go up there, turn on all the power, test all the telescope motions, rotate the domes, open the shutter, basically make sure it's going to work that night for the observer, whoever that may be. There are, I think, 88 steps total from starting up the telescope, observing all night, and shutting it down that the observer has to do every night to use and then safe the telescope at the end. Everything looks good. For me personally, it offers a way to introduce a cycle. Life is full of cycles, and this allows me to kind of get away from the daily grind, if you will, and just kind of observe. And when the sun sets, the domes can open. I do get that sense of awe looking up the night sky, and it is amazing how dark it is on Kitt Peak. You can actually see the Milky Way in all its glory.
It's really great operating the telescopes and seeing the images come in. Often the asteroids that we're looking at are not bright enough to be seen in one image. So we take a series of images and then stack them together at the point where we think the asteroid should be in each image. So we end up with a dot for the asteroid and a line for each of the stars. Spacewatch was started by Professor Tom Garrels and Dr. Bob McMillan in 1980, and we have gradually moved towards doing follow-up of newly discovered high-priority asteroids rather than doing survey.
I retired on paper in 2019, but I'm still around. I'm kind of proud of the fact that I've helped to steer Spacewatch into evolving priorities. When we started out in the early 80s, it was a real struggle. We did have a surprising amount of hostile peer review. And I think Spacewatch helped to make the search for hazardous asteroids respectable. Another milestone that occurred for Spacewatch was that in 1997, 98, NASA created a funding program specifically to search for hazardous asteroids.
So we have a NASA grant that funds our observations, and it is part of the Planetary Defense Coordination Office. So our goal is to reduce the uncertainty in our knowledge of where the near-Earth asteroids are as an act of planetary defense. And some of the more famous asteroids we looked at are Didymos, the target of the NASA's DART mission, the Double Asteroid Redirect Test. The goal was to nudge the asteroid by impacting it with the spacecraft. So they wanted to deflect the asteroid so that if it was one that could hit Earth, it would be moved. So we're not superheroes, but by being funded by NASA, we do fall under the auspices of the Planetary Defense Officer.
What makes this job fun to me is being able to be part of the entire cycle of operations, from designing the equipment to building it, to testing it, to using it, to submitting the data. I really believe in what I do, that there are rocks flying around in space, and one day a big one will hit us. It's inevitable. And I don't lose sleep over it, but I am glad there are people looking. And I hope that we can build a system that gets better and more efficient every year, and one day might help save civilization. It's great to be a part of that.
It's pretty exciting to observe an object that is a potential asteroid. And when you actually see it on the screen, blinking across the images, you're like, I did the job and I'm saving the world.